Okay, now we're going to be starting with, just really the basics, kind of the blocking and tackling, as it were. Primitive data types. Java has two types, generically types of data. One are the primitives, and the other are these object references that we'll actually be touching on a little bit tomorrow when we start talking about strings, because in Java, strings are objects. And then we'll dive much more deeply into it once we get into object-oriented design and classes and stuff like that. There are pure object-oriented languages, in which everything is an object. There's actually a very interesting language called Ruby that seems to have fallen out of favor. Is kind of a scripting language and a pure object language where, again, literally everything is an object, even numbers. Java is not pure in the sense it's been adulterated, as it were, by these primitive data types. So primitive data type is just a thing, typically a number. And then other important things that we'll talk about today have to do with scope. That's a really important concept. So I really want you to kind of get that. Java does most languages, with the exception of Python, do this fairly well. This is an area where Python, in my view, totally screws the pooch. Scope is an important thing in this context. It's going to be important because, at least for the Java programs that we'll be looking at, it helps you understand who can see what and everything. And then we'll look at escape sequences and operators and operator precedence and stuff like that. So there are a handful, 8 Java primitive types, and they have different value ranges. It is important to understand that usually at the edge. For most programming, it doesn't necessarily come into play. Where it mostly comes about is when we're trying to represent, say, very large numbers. So Java ints, being 32 bits, actually can represent a fairly wide range of things, except that sometimes you need more. And there are strange things that can happen when you try to assign a value to a type that's bigger than what it normally can handle. And Java will. Now, they keep changing this. Maybe at some point they're going to do something, but Java will often just silently do some weird stuff and not let you know, which is not great. So, and then determining the scope of a variable, that is, variables have, what is scope? We'll kind of get into that. There are escape characters, which it comes into play when we're representing certain things, and kind of what does it mean to have to escape? So when I say escape character, does that resonate? Do you understand what that is, or does that not make any sense yet?
Python has escape characters.
Okay, yeah. And then there's precedence, which is important to understand. But when you're writing stuff, for me, there's what I consider to be the prime directive of all programming, and that is the programmer's intent. In other words, when you write code, it should be absolutely clear to somebody, or as clear as possible to somebody else who is reading it, exactly what you intended to do. And notice the word intent. Intent is different than what it does. There's what you intended to do, and there's what it does. Because computer programs are just as stupid as, well, they're really stupid things. Because they do exactly what you tell them to and not what you want them to. They do what you tell them to do and not what you want them to do. So you want them to do something, but you've told it to do something else. So when your program is doing something really weird, it's because you told it to do that. And if it's doing something weird, it means you meant to tell it to do something else. Okay. Data types. Two types of data, primitives and reference. We will be dealing a lot with reference variables, but we're going to start with primitive because that's the more primitive one. Okay, basically here they are. There are 4 variables that represent integer values, and those are actually in increasing size. There's a byte, there's a short, there's a long, and there's an int, and then there's a long. So mostly we'll be dealing with ints. Occasionally we'll have to deal with longs. There are 2 reasons why we have to deal with longs. One is when we have to represent numbers that are too big to handle an int, and that's why it's important to know how big a value an int can hold. The other context is that often when, and I found this when using certain libraries, if I'm using a library, a lot of times things like the return value will be a long, and have to deal with that. Or the argument that a method needs is a long, and so you have to give it a long. Shorts are actually, that's kind of an anachronism from C. And one of the reasons why it's important to at least understand a little bit of where these came from is to understand the environment in which many of these languages arose. The granddaddy of modern languages is the C language. And the thing about C is that C was developed in an environment where computers were physically large and logically tiny. So in that context, you had to squeeze every last little bite out of things. And so if you're representing, so there they said, sometimes we have to represent things as an integer, and so, but if we only need a relatively small range of values, then we can save some space by making these short things. So a short is something that uses less memory, and that's how it arose. Now the irony is that in the Java virtual machine, shorts, you think, well, shorts are half as big as an int, so if I use a short as my variables, knowing that they're not going to take such large values, I'll actually save space. The irony is that in Java you actually don't save any space, because in the Java virtual machine, shorts are actually represented by the first 16 bits of a 32-bit word. So you actually don't save any space at all. And so you should never use shorts, ever. Doesn't save any space, and it just confines you to a very, very small range of values. Bytes, we will ideally not have to encounter too much. Sometimes when we're doing input and output or sending data over the network or something, then we have to deal with byte streams and stuff like that. But that's a relatively low-level type of thing. Okay, so for integers, ints would be the default. Occasionally we have to use longs. Okay, for representing decimal values, Java provides 2. One is double and the other is float. And then floats, again, is a bit of an anachronism from C in that they used less space. And so Java, a float only uses 32 bits, whereas a double, it's called double because it uses 2 words. Again, Java was developed when the basic word size was 32 bits. So now in 64-bit context. The double is actually just a single. So again, floating, the problem with floats. The problem with floats is that when you are using doubles, you are often doing computations. And when you're doing computations, floats do not have enough precision for almost everything that I've encountered. So again, so floats, you should never use a float, basically. Only use doubles. And so the other primitive type is Boolean, or our Boolean. And so a Boolean has two values, true or false, and these are keywords. So you would just sort of type true or type false. In Python, I think they're capitalized. There's a similar thing you've probably dealt with. And then the other is a char, which is a 16-bit thing, which we'll play with a little bit, but again, that's sort of a low-level thing. Okay, so here are the different numeric types and their sizes. So a byte is 8 bits and can go from -128 to 127. A short is 16 bits and can go from -32,768 to 32,767. Whereas an int goes from this number to that number. And a long basically is a really big number. It can represent big numbers. The important thing to kind of, really the important thing here is this value right here. Because every now and then, computations will reach values that are greater than that. And do you know what happens if I have like in this case, like an int, and I do a computation and it exceeds this value? Do you know what happens? It wraps around, basically goes negative. And that's because the bit that says whether it's positive or negative it gets filled with something. And so it goes from a positive bit to a negative bit, and then you just get this weird stuff. So it's like, I thought I was getting a bigger value than this, and in fact I'm getting this huge negative value instead. So that's kind of off. Again, longs are even bigger. So what's the lesson is that if you want to represent really large values that are integer, then you want to use longs. Again, floats, it looks like it's kind of big. Again, the problem that I have run into with using floats for computations is that you lose a lot of precision in the computation. I mean, they can actually represent fairly large values, but when you do the computations, you lose a lot of precision. The thing to understand, especially when it comes to trying to represent floating point number, decimal numbers, is that a digital computer cannot represent a decimal number, a floating point number. It can't. Why? Because a digital computer, by its very nature, is integer. So what they've done is they have this way of representing double values, but they can never represent them exactly. And so the implication of that, there are a lot of different implications that we will encounter. One of the implications of that is that if I have two double values and I want to decide whether or not they're equal, then you would think, you've all encountered the double equal thing in Python, right? So what does double equal say? It says these two things are the same. If I have two integer values, they're either the same or they're not. Whether it's an int, a long, short byte, they're either literally the same or they're not. If I have two double precision, floating point values on a digital computer, they may appear to have the same value, but I can't count on them having exactly the same value. So if I if I'm saying, are these two values equal, they may actually be numerically equal in terms of calculation, but they will not literally be equal on the digital computer because it cannot represent them exactly. And if I have two values that I'm comparing, and if there is one bit that's off, then equal is false. So it's important to understand that. So if I want to compare these, I can't just say double equals. There's also, when we talk about strings tomorrow, there's also a little gotcha when it comes to strings being equal or not equal. Okay. So, representing numbers. So here's literals. So I want to represent an int, so here's an int. Okay, easy zippy. What if I want to represent a literal long? I say 42L. So these are two different numbers. Okay, this is an int that has the value of 42. This is a long that has a value of 42. And internally, this is represented by 32 bits. This is represented by 64 bits. Now, and if I want to make sure that this value is in fact a long one, I have to put the letter L after the integer value. Now, Java lets you put a lowercase l as well, but notice that I've used an uppercase. You should always use an uppercase L. Do you know why?
Looks too much like a number.
Yeah, a lowercase l looks a lot like a 1, so if I'm just kind of looking at it, I can't really tell. An uppercase L can't be a mistake for anything else. In Java, the default, and this should give you a clue about the default for a decimal number. So if I put a 3.14, is the default is a double. If I want to represent it as a float, I have to put an F there. And the F can be uppercase or lowercase, but again, that shouldn't matter because we should never use floats. So in particular,
One question.
yes?
How does literal look for short and byte?
For shorts and bytes, you would have to basically represent them as an integer and then cast them. So that. And then, okay, now a char, we use, there's a single quote to distinguish them. And this is different than for some reason in Python, if I want to represent a string, I can either use a single quote or a double quote, right? But in Java, they mean different things. In Java, a single quote is for a char, and a double quote is for a string. And the other thing to recognize is that, and I probably should have had this in the example, and this is something that I want to encourage fairly strongly, if I'm setting double values, I want to always put a decimal point, and so if I want to represent the number 42 as a floating point number, I can, as we'll see, if I have a variable that's a double and I assign it the integer value 42, it will kind of up-level it to a floating point value. But I don't want to do that, and that gets back to the prime directive of programmer intent. If I write this, then the assumption is that I intend this to be an integer value. And so if I assign it to a double variable, then I've kind of misled. I haven't been really clear. If I am clear that I want a floating point value, even if it's an integer value otherwise, then the criterion of programmer intent says put the decimal point in explicitly. And that makes it clear that as a programmer, I meant this to be a floating point value and wasn't just sort of playing tricks. Okay, we're going to delve into strings a little more deeply tomorrow, but string literals are, we enclose in double quotes, not in single quotes. But the thing is, strings are not primitive types. Strings are actually objects. So we use single quotes only for characters. Okay, so here, Java is a strongly typed language. And what that means is that every Java variable has a type. And once you declare that type, it cannot be changed. If I declare a variable to be an int and later change my mind and say I want this to be a double, Java will not let me do that. Why? Because why would anybody in their right mind do that? Laziness, mostly. So there are some implications of this, and this is why Python is a much easier language. That's why it's so popular. It's easy, and how to use it. You don't have to declare a variable. You just start using it. In Java, you have to declare the variable. You have to say, before you do anything with this variable, you have to say, this is what it's going to be. This is the type of data that this is going to hold. And once you've done that, there's no going back. Whereas, scripting languages will typically let you take the same variable and put a number in, put a string in, put it back to a number, whatever, and say, well, that makes life easy. Well, it makes life easy maybe for the one writing it because you can be really lazy, but it makes life hell if you're trying to debug it. Strongly typed languages are a necessity if you're writing a large program. If you're writing a little script that's going to be no more than a page, it doesn't matter so much because everything is right there. If you have a large program, and the programs that I write tend to be very large, strong typing is it's not an option, it's a necessity. It is an absolute necessity. So a Java variable, you have to first declare what type it is, and it can only contain values of that declared type. Now the value can actually change, but now we'll kind of get into this, so you just kind of tuck this away. There is a keyword called final, and if I declare a variable to be final, it means that I can only assign it once. And then after that, the compiler will not allow any other assignments to that variable. That's actually say, well, why would you want to do that? Well, there are reasons for that. Now, so that's each variable. Okay, we're talking is either one of the 8 primitive types or an object type. That's one dimension. Now there's another dimension, and I don't know another word, but it's like where variables show up in the program there are 3 places. There are local variables, there are instance variables, and there are class variables or static variables. And what's the difference? Well, the difference is, and we'll delve into this a lot more, and it will hopefully become a little more obvious once we start writing more code. But local variables exist only in the duration of a single method call. And when I say method, you can translate to function in your minds if that's what you're used to. But method, function. Functionally, methods are the same as functions in most respects. So a local variable only exists for the duration of a single method call. An instance variable is one that actually persists throughout the life of an object. And all of this will make a little more sense once we delve into objects. And then class variables exist basically throughout the whole program. But scope is kind of something which comes into play there. And we'll circle back to that. Okay. Now, naming conventions. Now, this is something where Java lets you call things in all kinds of ways. There are certain restrictions, like variables can't start with a number, but you can have numbers in variables, so it has to start. But in every language, there are naming conventions, and it behooves you to follow those conventions. Why? Because and they're very different. So the naming conventions in Python, for example, are very different from the naming conventions in Java. In Java, local and instance variables, they use something called camel case. Are you familiar with that term? Yeah, so it starts with now variables, we're talking variables, they start with a lowercase letter, and after that, they only use letters and numbers. Now, you're allowed to use underscores as well. You can also use things like dollar signs and some other things, but the convention is you only use letters and numbers and avoid underscores. Now, this is in contrast to Python, for example, where the convention is that variables are all lowercase and you use underscores. So if you're writing in Python, those are how you should name your variables. And if you're writing in Java, you should use camel case. You know, why is that important? Well, it's mostly for perception. Like if I'm reading some Python code and I see camel case there, it's probably a Java programmer who's writing Python, which means that they're kind of an interloper. Likewise, if I'm reading a Java program and I see a bunch of underscores, then it's probably like a C programmer or a Python programmer who's bringing their stuff in. In other words, it's like when in Rome and all that. You use the idiom for whatever language that you're working in. That's important. Okay, so how do we get these things into these variables? Well, and it's important to understand that in each of these lines here, there are actually two things going on. And if I get a chance to just show some examples, I like to kind of actually separate them just to demonstrate the fact that there are two things going on. So right here, I declare an int variable called number reps. Okay, that's one thing. And I can do just that one thing separately. This says for an already defined variable called number reps, I will now give it the number 3. Okay, so there are two things going on here. One is I've declared the variable, and then the other is that I've assigned the variable. And then in object-oriented design, we almost never do it this way. In good object-oriented design, you always declare your instance variables as separately, and then you assign them inside of a method or a constructor in two different places. Where do you do something like this? Usually in classroom demonstration situations. In a production program, you almost never do this. But nevertheless, it's important to understand how this goes. So here's a number. If I've done this the way I intended, here's a number that is too big to represent as an integer. So if I try to type in this number and I leave off the L, then actually Java won't let me, or NetBeans won't let me do that. If I'm doing it in a text editor, I can do anything I want. But NetBeans is smart enough to know, hey, you're trying to represent a number that's too big. So I have to put the L there, and I can assign it to a big number. So now here I have this note, there's no L here. So this is an int, and I assign it to a long. And what it does is it promotes it. So now at this point, I take an integer, an int with this value, and it turns it into a long with this value. Java lets you do that mostly for convenience. This is kind of it's not a mortal sin, but even if I were doing this, you really want to put the L in to programmer's intent again. Now this won't work here because I'm trying to put a number that's too big into an int. So just every now and then this comes up. Again, now a double, I don't have to do anything. Here, I take an int and I convert it into a double. And again, stylistically, this is something that I'm going to discourage. That I discourage, again, why? Because this is laziness. I mean, it's like, it always kind of blows my mind. It's like people get cramps in their fingers if they have to type a little bit too much. So how much would it take to type in .0 here? Oh, my fingers hurt. Okay, avoid using floats, so no examples for that here. Okay, so true and false are reserved keywords. So if I want to set a Boolean to true, then this is how I assign it. Yes, question?
I don't really get why we declare a small number to be a long variable, and we also have to write the L when we assign it. We already declared it, but like
I mean, now are you talking about this line or this line?
the
Second
second line.
line. Well, that's what I'm saying. You don't have to. But what is my intent here? My intent is, since I'm assigning this to a long value, did I really intend this to be a long or an int? In other words, what I'm encouraging is to have coherence between the value that you're creating and the value that you're assigning, and not to rely on the automatic conversion. I mean, in fact, and just as a general principle, it's best to avoid sort of the automatic anything, but to be really explicit about what you're doing. So it's a stylistic thing. Java will let you do this. It's not the worst thing in the world. I mean, if I see something like this, it's sort of clear what your intent. But there's always that small little bit of doubt. So if I see the L there, then there's no doubt whatsoever. I meant this to be a long value. So, but that's your mileage may vary on that, but it just my prime directive is I want to make it as absolutely crystal clear as possible what I intended to do. And any ambiguity or any dependence on an automatic change is going to have a potential of breaking that. Was there another question over here?
I had a question, but maybe not answered.
Oh, okay. Now, every now and then, we need to kind of deal with it. This is Java was one of the first languages to use Unicode instead of ASCII. ASCII is this sort of ancient a form of representing characters that they could basically do letters, numbers, and a few special symbols, but it was very limited. Unicode, all of a sudden, you can represent all kinds of things. So you've seen things like in Cyrillic, like if you go to a certain page, if it's like from Russia, you'll see it in Cyrillic. If it's from one of the Asian countries, you'll see it. You'll see the kanji characters or Chinese characters or whatever it is. How do you do that? You can't do that in ASCII because there was no room for it. You can do it in Unicode because Unicode just has all kinds of stuff in there. So Java supports that. So, where does that come into play? It comes into play when at the character level. So a character letter, here's the capital letter X. Now characters are also numbers, and I would not, I kind of discourage this, but this is absolutely possible. This is actually the same character, but the number 88 is a capital X. Now a Unicode escape character, if I again, notice it's in single quotes, so it's a character, but if I start with a \U and then give the Unicode code, then that will also print as a capital X. And then, okay, it's kind of hard to tell. This is a 0 here. If I start a number with 0, it's an octal. Okay, so these all have the same value. Again, we can verify that. I'll do it. Okay, so escape sequences, like basically there are. Sometimes we want to represent usually a non-printing value. So a backslash, is \B. So when you're printing something out, we can actually kind of go backwards. If I want to represent a single quote, then I usually would say within a string. All of this is typically within a string context. A new line, \N, you've probably encountered that before. A form feed, which is, again, that's an ancient type of thing. A tab, this is something that comes up at \T, you probably encountered that. So here's the trick. If I have a string, so let's say inside of a string, I want to represent a double quote. The problem is if I just put another double quote in there, Java will think that this is the string. If I want to say that this is, I don't want to finish the string, I actually want to print a double quote, then I have to escape it. And so, we will encounter this when, at some point later in the course, we will look at something called regular expressions. And in those, we will have to use, there are a lot of escape characters that we use in that. So if I want to represent an escape character in the string, then I need to escape the \, because otherwise it'll think the \/ is actually escaping something. So what it'll do is it'll read the first \/ and say, you're going to escape the next character, meaning it's going to be literally, it's going to be whatever this one is. In this case, it's going to be the \. Got that? And then mention this, or if I want to represent an octal value, I start it with a 0, and if that should be a single quote. For a Unicode value, \U. Okay, scope. This is now this is something you're going to hear me kind of carry on quite a bit about. Unlike Python, so for some reason Python, I think whoever wrote Python was under the impression that somebody got a royalty every time you hit a curly brace. Pretty much every other language kind of groups things using curly braces. For some reason, Python didn't want to do that, which is like one of the worst things about Python is the fact that spaces actually mean something. But anyway, I'm not here to complain about Python. I'm here to extol the virtues of Java. So in Java, curly braces are meaningful, and that's how we define scope. So you've already seen it in our in our main method here. So the open curly starts the method, and then the closed curly ends the method. So here, now we can also choose to just create a little block by delimiting and by curly braces. Don't have to do that. I usually don't do that, but it is possible. But okay, what is meant by scope? Scope is the area, the region in which a variable exists. So if I've done this, the scope of this see, notice I've declared this, it's the scope in which the variable has been declared. This variable scope is only within these curly braces. So if I then try to access this variable outside of its scope, it's an error. In other words, outside of these curly braces here, that variable does not exist. It's important to understand. And this concept doesn't even exist in Python because there are no curly braces. They want it. Okay, so that seems kind of weird. Now, scope kind of goes inward. So here's the similar type of thing, except now I've declared the variable outside of this block here, but since this block is within it's kind of inside, it's nested, and so this is okay. In other words, this variable exists because it was declared out here. Do you see that? Is that okay? And we'll be kind of touching on this important scope concept throughout because it's important. If you using the scope concept, just a lot of things will start to make sense. Hopefully, yes.
So my other question is, the first one with the error, what kind of error that showed in the other NetBeans?
I think NetBeans will give it what's called the red squiggly of death, which is, it says, hey, this doesn't make any sense. Yeah. If I did, without NetBeans, if I were just doing this in a text editor, it would let me do it, and then when I tried to compile it, I would get a compile error. And you'll hear me kind of rant about that a bit. Java is, it's compiled and then quote interpreted. Why is it like scripting languages are typically purely interpreted, so it's like it reads the code and executes it. What's the problem with that? And I've literally encountered that. I had a Python program that ran for a half hour and then exited with an error because of syntax. Why? Because that particular code hadn't been touched. And then as soon as it was touched, it said, oh, hey, this doesn't make any sense. In Java, that will never happen. Why? Because the compiler will not allow any syntax errors to get past the compiler. So you can't even run the program until the compiler says everything is okay as far as the syntax goes. Now that, and then of course now you have runtime errors, which is kind of another thing. Okay, arithmetic operators. This is again. This is much of this is review, but I'm trying to touch on the places where Java is a little different. So, strong typing variables. That's different than what you've encountered. The scope concept, again, that's different than what you have in Python. But addition, subtraction, multiplication, division, modulus. Those are all ones you're familiar with, right? Java has no exponentiation operator. That's something I wish they did have. In other languages, like a double star will do an exponentiation. Java tried to be simple and not have it in there. But hey, yeah, that's okay. Precedence, though, and now this is something that you're. They must have covered this in Python, right? Precedence. So basically, Now, each language is a little bit different in this, but I think Java's pretty much standard in this. So multiplication, division, and modulus have precedence over addition and subtraction, and then within the same precedence, it goes left to right. So, for example, and on the internet, you've probably seen these. You know, they'll put an expression like this up there. It says, "What is this? Is it 24 or is it and of course, people who don't deal with precedence get it wrong. Okay, so the result is 10. Why? Because multiplication has more precedence. So first you do this, and then you do the other. If you want to. Now, if I wanted to have the addition first and that, I put parentheses, okay? Now, but here's the thing. Stylistically, again, don't rely on precedence for an operation. In other words, this is, in my opinion, very bad style. I would still put the freaking parentheses in, even if precedence says it, because this makes it absolutely clear that that's what I intended. So again, the overarching principle is don't rely on automatic stuff. Make it absolutely clear what you're doing. And so what is the cost of this? I have to hit parentheses keys twice. And if that's too much work for you, then you probably shouldn't be writing programs. So for when you're doing expression, always use parentheses because you want to convey the intent. And then finally, assignment. Now, this is sort of one of the weird things, at least from a math perspective, a lot of times it doesn't make any sense. The thing to understand, and this isn't always made clear, is that the right-hand side of an assignment statement is an expression, even if it's just a single value. And the left-hand side is always a variable. There's no other way to do that. Now in Java, and this is where it's different than loosely typed languages like Python, the type of the expression must be compatible with the variable type. And by compatible, now there are some upgrades. So in this case, so here I have double net pay is gross pay minus deductions. Now if one or both of these are integers, it will upgrade it. Normally this would be, well, actually, just sort of as an aside, when you're representing money, it's actually best to do that as integers rather than doubles, but that's, okay, so here expression, double, the blah, you've done kind of all this. Again, what I would encourage using parentheses here, just to make it absolutely clear. The number of groups class size over 4. Okay, so here's the trick, and this is sort of the gotcha on this. Let's see, do I do more? Running out of time here. All right, supposing class 5 is 15, and so then I divide by 4. What value do I get here? 4? I get 3. Okay, so that's the gotcha on integer division, and it's a consequence of strong typing. That is, if I have 15 divided by 4, the value of this expression must be an integer. Now, which integer is it? And it is kind of arbitrary. It could have been 4. They could have said, if it comes out close, we'll round up. But they don't. It truncates. So just important to understand. And is that a law of nature? Absolutely not. There's no reason it couldn't be 4. They could have decided it before, but they didn't. They decided to truncate it. So the value of this is 3. Okay, that comes into play when you're doing certain types of computations. Now in this case, there was sort of if I wanted to, just as an expression, I could have cast one of these. We'll try to get to that. Okay, so when I have a mixed expression, the value of the expression is going to be promoted to the broadest type. So, for example, an int times a long is going to be a long, because that's the broadest type. An int times a double becomes a double. Now, I can cast a narrower type for a broader one always. So if I take an int, I cast it to a double, then it becomes a double, no problem. If I cast an int to a long, that becomes a long with no problem. If I try to cast a broad type to a narrow type, the results are kind of unpredictable. So if I have a double value and I cast it to an int, then it's going to truncate. Even if it's, I probably should have made this like 1.8. If I made it 1.8, it would still be 1. It truncates. But you got to be careful. So here's an example where I have a long value which is bigger than an int can handle. If I cast it to an int, again, it goes negative, as we said before. And as we'll see some examples of this as we kind of go along. Okay, I'm a little over time here. You're familiar with the increment and decrement operators, and basically they're one of these things where there's only one context that I approve using it, and that's inside of a for loop. Okay, so next steps. Okay, read on to the next section. Have Apache NetBeans installed. If you haven't done the GitLab thing, get that done. And I think most of you have done it. I think there are just a few who haven't. And you should have. Did everybody receive an email back from me about access to my? So when I do coding here, I'll do a lot of coding in class, and I'll commit it to that, and then that's something that you'll be able to download to your NetBeans and take a look at. I'll show you how to do all that next time.